For the third example, we will have a look at the basic handling on performing RMS simulations. The idea of this exercise is to go through the required steps so we get an understanding on the overall procedure. To start, please activate from the project overview window study case number 3 named Transient Stability. This transmission system example contains already the dynamic model definitions of the controllers of the generators. This can be observed by clicking on the Edit Relevant Objects for Calculation button and looking for composite models and common model definitions, which is how the controller dynamics are defined in PowerFactory. If we click, for example, on the composite model symbol, PowerFactory shows a list of all the composite models that will be considered in the simulation. By double-clicking one of them, for example, generator S2, we can view the different dynamic controls that are defined. Here we notice an AVR, governor, and power system stabilizer defined. If we double-click on one of the elements, we will have access to its parameters. We can have access to the same information by clicking on the element from the single line diagram. In this case, generator S2. From the basic data page, click on the plant model button, which will be pointing to the composite model. In general, the steps we need to perform are the following. Calculate a load flow, calculate initial conditions, define events, define variables to monitor and plot, and start the simulation. If we don't have a valid load flow solution, meaning if we don't have a convergence, or if we have a model error because of a missing type of an element, we will not, of course, be able to continue with the procedure. It is also important to mention that the starting point of the simulation will be based on the load flow solution, meaning that the settings of the load flow command will play an important role. The starting point will be also influenced by the operation scenario considered, if any, and or the active variations and expansion stages. We will consider in this case the reactive power limits of machines, and in the active power control section we will perform it as dispatched, meaning that it will be balanced by the reference machine. Once we have calculated the load flow, we can proceed with the RMS simulation. First, make sure that you have the correct toolbar selection, which should be selected as RMS EMT simulation. A group of buttons will appear related to this functionality. Click on the Calculate Initial Conditions button. In the command dialog, we will select the simulation method RMS values, and since we will be performing a three-phase fault on one of the 225 kV transmission lines, we will select the network representation as balanced positive sequence. In the step sizes section, the step size and the start time can be specified. We will leave this unchanged and click on Execute. Now all the signals of the dynamic models and the built-in models are initialized based on the load flow solution. As a next step, the events and variables definitions must be stated. To define the event, simply select the element from the single line diagram. In this case, we will select a 225 kV transmission line, which is connected from substation 2 to substation 4. To define the event, simply right-click on the transmission line, go to Define, Short Circuit Event, and in the Event dialog, we will need only to specify the type of fault and the time at which it will be applied. Let's leave 0 seconds and define a three-phase fault. It is important to note that the option available should be selected on the line. Otherwise, the event will be ignored. To verify this, we simply go to the line by clicking on the blue arrow pointing to the right, go to the RMS tab page, and select the available option. Here you can also specify the short circuit location. we will leave it at 50%. If you were wondering, this 50% is based on the I terminal. We will click on OK. Now we need to clear the short circuit. To clear the short circuit, we will simply trip the line after 100 milliseconds. We will need then to define another event on the same line. Select the line, right mouse button, define, switch event. In this switch event dialog, we need to specify also the time and the action. In this case will be opening of both breakers, that is, at both ends of the line. We will specify then 100 milliseconds later. We will click on OK. If you need to make modifications on the events previously created, then simply go to Edit Simulation Events button. Here we will have a list of all the events created. To edit one of them, simply double-click on them and make your corresponding changes. We now need to define the variables to monitor, or the variable results. For that, we will do this also from the single line graphic. We need only to multi-select then the corresponding elements. We will select, in this case, several generators from several power plants and also a couple of lines. So click on one of the elements, hold down the Control key, and then click on the other elements that you would want to then to monitor. So we said a couple of generators, maybe a couple of lines, transformers, and why not also some bus bars. Over one of the selected elements, right mouse button, go to Define, then go to Variable Set, Sim, that is, for simulation. PowerFactory will open then a list of the selected elements. By default, PowerFactory also selects a certain amount of variables to be monitored. For instance, in bus bars, if you double-click on a bus bar, the variable selected in this case is a positive sequence per unit voltage. In the case of generators, you have also a list of selected variables already predefined. And in the case of lines and transformers, it's the same. If you require other variables to be monitored, then you simply select it from the corresponding variable set and enable your selection. We will leave it at with this selection. If you want to return to the variable result definition, then you will need to click on the Edit Results Variables button. So we are already set. We only need to then start the simulation with the corresponding button. Specify the absolute time or the stop time of the simulation. Let's perform it to 5 seconds. Press on Execute. You will notice there at the bottom of the screen the time. Once the simulation is finished, we will need to then plot the results or create our simulation plots. We can create the simulation plots by clicking on this button. We select then from the bottom of the dialog the corresponding element, double-click on the empty cell. Let's say we want to select first all the generators, so we can multi-select from this list all the generators. Click on OK, so you will see them appearing in that sequence. We need also to select then the corresponding variables, so we double-click on one of the empty cells, and there you will have a selection of variables. We can select, in this case, for instance, the rotor angle with reference to the reference machine and say OK. We can also assign the same variable to the other generators, so we can simply copy and paste the information. We can change the coloring, the style, and the width. We will say here OK. A plot will be automatically then created. We rescale it from the x-axis. And then we rescale it then from the y-axis. We can add more plots by selecting the complete plot, left mouse button, so it's marked, Ctrl C, Ctrl V, so we have another copy. We modify one of those, since it's a copy, and select another variable, such as speed. And we copy the speed for the remaining generators. We rescale, and there we have the plots. As a suggestion, we recommend that you take a look at the output window to see if all the events were carried out as specified.